Okay. It looks like we are therefore going to conclude on the introduction of this topic, the pulses and waves. So let's quickly summarize, honorable member, but most importantly, you need to remember that when you talk about a pulse, it is just a single disturbance that is propagated from a source through a medium. That's it, honorable member. But when it comes to a wave, it is therefore a repetition of pulses at regular intervals. That's it. So you can see there we are having two columns where we are going to be talking about the transverse and the longitudinal. So maybe very quickly, let's discuss all in summary regarding a transverse pulse, whereby we say a pulse being a transverse pulse, it is a pulse in which the particles of the medium move. Most importantly, they move perpendicular to the direction of of propagation of the pulse. Perpendicular, which means the movement can be in that direction, but they move at 90 degrees or perpendicular. The 90-degree angle is formed there where the movement is towards the left or the right, but the particles are going at right angle to the movement or perpendicular to the movement. So that's where the 90 degrees comes in. Obviously, we did have a look at that diagram where we had that rest position, and then that being formed whereby that distance from the rest to the peak or the highest point, that distance is the amplitude. And then from the start there up until the end there, so that distance, it is our wave length. So a transverse wave, it is therefore a succession of transverse pulses. For example, we can be talking about a water wave. That is a real a situation where we can visually see a wave being the water wave, whereby a repetition of those, they form a transverse wave, where we are looking at, let's see, this diagram whereby when you look at this part, it seems as that diagram that we've just discussed, whereby we do have that distance being the amplitude. And then from there, the same thing, but it looks like it has been flipped or continues in that. So we know that from the zero to the highest point, it is the amplitude. And then in terms of the wavelength, it starts from there all the way up to there. So this highest point, it is being referred to as the crest, and then that one, the trough. So that's it, honorable member, or the member who is honorable. So yes, lastly, very much important, we did talk about the frequency, which is the number of waves per second. And what else did we talk about? We also talked about the period, which is the time taken for one complete wave, which is measured in seconds. This one is measured in hertz. Okay. Then now they talk about the wave speed. Okay. The wave speed, we are therefore referring to the speed of a wave through the medium, where we are having that formula being equals to the speed, or v for the velocity, which is equals to the frequency times the wavelength. So that's it with regards to the transverse. Most importantly, looks like we are just summarizing all that we have discussed. So now when it comes to the longitudinals, a longitudinal pulse, this one, it is a pulse in which the particles of the medium move parallel to the direction of the movement of the pulse. Most importantly, if the movement is towards the right, even the particles move towards the right. So you can see the direction is parallel, unlike that other one whereby when the others are going towards the right and then the particles going up, forming a perpendicular type of a thing there. But this one, it is parallel movement in that direction, particles in that same direction. So that is the difference between the two. And it looks like this one of the longitudinal, it doesn't have too many stories there. I think everything is straightforward. So now, obviously, we can see that section there where things are highly compressed. That is the compression followed by the rarefaction, and then compression, rarefaction. Okay, then it's fine. That would be a longitudinal pulse. But when it comes to a wave, meaning a longitudinal wave, it is therefore a succession of longitudinal pulses. For example, in real life, we can talk about a sound wave. So a pulse, many of those, it becomes a wave. Something of that nature, honorable member, whereby you will notice that, yes, we have that compressed rarefaction, compressed, rarefaction, compression. And then, obviously, in terms of the wavelengths, you do know very well that it will be from compression to compression, rarefaction to rarefaction, compression to pressure, and so forth and so on, stuff like that. That one, it doesn't have too many stories. Straightforward as, okay. Some key ways to remember there, it is that superposition which refers to the algebraic sum of the amplitude of two pulses that occupy space at the same time and at the same space. I think was it the first or second lesson? I think we did touch on that and did some calculations. Then constructive interference. So that means waves can interfere constructively or destructively. So the constructive interference, this is the phenomenon whereby the crest of one pulse overlaps with the crest of another pulse to produce an increased amplitude. I think this one is clear. They constructively interfere. And then the ones where they destructively interfere, that's when the crest of one pulse overlaps with the trough of another pulse, resulting in a pulse of reduced amplitude. So looks like crest to crest or trough to trough constructive interference, as long as we have an increased amplitude. And then the ones where we have a reduced amplitude, we therefore talk about the destructive interference. Okay, wavelength. This is the distance between two consecutive points in phase. It is as simple as that. That is the way. So this type of information, or this information, might be useful when it comes to those type of what is it? The multiple choice type of questions, or where they want you to define something. You will definitely need this information. And the amplitude, obviously, it is the maximum displacement of a particle from rest position. So its highest point from rest position. So that maximum displacement from the rest position, it is the amplitude. I think not that much complicated that part. Okay, looks like we did cover all that we could. We can therefore leave it here and say until